Hi, welcome to Module 11. What I'll do with these videos is kind of give you an overview of the material. I'm not going to go reading at PowerPoint slides to you. You can do that. You can read the text too. Um, just keep in mind that I'm here to help. So as I go through these, if you need less data, more data, give me that feedback so as we can improve the class as time goes on. So what I'll post in every, like I mentioned in the Start Here video, each module is going to get a set of learning objectives. And this learning objective is broken down into three different areas. One is the interpersonal system. How do I treat people when I'm dealing with them? Now you got to think of this as a computer IT point of mind, point of view. The second area this chapter goes about is what kind of systems and documentation do you put together to make sure that systems stay up and running, that computer networks stay up and running, that businesses stay up and running as they're growing, evolving, as new software applications be developed, and as new data is being, hardware is being developed. What types of things do you need to think about, both from a, because an IT specialist doesn't just deal with end customers. You may deal with internal customers, and you may have to make a change. You may have to change out the operating system for 1,000 computers, or you may have to change we're adding a new room or a new floor or a new building. How do I do that? What do I do if somebody calls in with a problem? So this chapter talks about a lot of those areas. And then it talks a little bit more about uh, the different types of software that you may deal with. Since this is still based on an A plus certification and is vendor neutral, you, based on which company you're going to work for, you may deal with one, you may only be dealing with a Microsoft Windows application house, or you may be dealing with just Apple products. Some organizations have a variety of different vendors. They don't care. It's up to each individual bringing their own in. And then you have to be prepared to understand all these different environments. So that's kind of what this chapter is starting us out in trying to lay that foundation as far as how complicated this IT world is and how fast it's changing. So what I'll also be doing in each week or each module is I'll either give you one, internet sources, links to other applications or other authors' points of view on these things, how to manage users, an overview of different operating systems and how they work. So sometimes I've had students find that just getting something different than my expertise or the author's point of view, these are just extras. So sometimes I'll post videos, sometimes it'll be just websites, but either way, there will be other resources that you can use if you so choose. Just a reminder in the assignments, all the assignments are due midnight, August 28th. So that gives you what, approximately 13 days or so if you start on the 15th. So it gives you some time. Um, I've got in this section, I've got I think this one's the reading, which we'll click on and double check that. I've got 2 software simulations to use on that, and then the exam. The exam is 20 multiple choice. You got 30 minutes, giving you 2 attempts. I take your highest score. So you click that link when you're ready, and it will take you to the exam. So let's look at some of the material in this chapter, this module. Now remember, we're starting on module 11, not module 1. So, because this book is used both for the hardware part of A plus and the software part. So if we look at clicking that link, hopefully it'll come up. And when it comes up here, it only took me to the class. You want to get down to, because I've given you, hopefully you see 0 activities for everything prior to that, but module 11, we're going to go to learn it, and then we want to read the material. Now, there's other materials available to you. If you like PowerPoint slides, flashcards, practice quizzes, before you take a test, it's not a bad thing to try. But I'm not going to assign it. It'll be there for using. As you can see, it says practice, so you should be able to go through this. But I'm only going to take us to the textbook. And it took me all the way to the end. So there we go. So what we're going to look at here is look at probably what most business owners crave. They crave this 11.1 is because every business probably can teach you the technology of their business, and they're very good at it. But what they have a harder time teaching new employees is how to be a nice person, how to treat other people, how to listen, how to care. Those are crucial skills, because there's not one project that I've worked on in 30 years of industry work that I was by myself. Even when I was new to the job, I was never by myself. I may have been given a program to write or a memo to write or a spreadsheet to work on, but I had to work with other people to get the right information to make that happen. So you had to learn how to work with other people. So that first 11-1 is so crucial to this, to your career as far as an IT developer. Now, the second section, this documents and support systems, is what types of information is required to run a project, to run an IT organization. So what kind of documentation, what kind of support systems are in place? How do I deal with a change of the system? So I want to switch from Windows to Apple. What do we have to do? How do we plan that? That's what this section goes into. And then this last part, this 11.3, is starting to introduce you to what an operating system is. I mean, even though we're talking operating system, you're talking about, you've got an iPhone, it runs a certain operating system. You've got a Google phone, it runs a certain operating system. You have a PC that's running Windows. It operates differently, except all operating systems, let's just take a quick look there. Every single operating system does the same basic things. Now remember, an operating system is just software that connects you. It's kind of middleman between the application you want to run and the hardware that you're on, whether it's your MacBook, your laptop, your desktop computer, even your phone. You've got an operating system, you've got a set of software that controls the interface between the two. So, and this is just a good example. You've got a user application, and in there are different physical devices that are used to allow you to use the application you want to do. You want to send a text message. Okay. You know what application you want to use, but you still have to do what? You still got to touch that icon on that. So your hardware has to then determine, oh, somebody's touched my icon. That means I have to do something. Your operating system is that in-between piece that goes through that. It goes from your motherboard to video cards to hard drives. So that operating system is the one that's controlling the interface between the two. So there are four major functions here that every single operating system does. And if you remember these four things, then as you deal with different operating systems, you can kind of look at it through these eyes and say, okay, I want to make sure that how is it doing the user interface? How is it recognizing what I'm asking it to do and interfacing with what's in the computer? How does it manage its files? How does it manage creating them, storing, retrieving, deleting, and moving them? How does it do that? Every operating system manages hardware. It interfaces hardware that's permanently stored on your computer. It manages your memory. It gives you tools to diagnose problems both in hardware and software. It does that interface between the hardware and software. And then, of course, the last thing it does is it manages the application. How do I install an application? How to remove an application? If it's running, can I have multiple applications run at the same time? Every single operating system has those four pieces. So when you're thinking about doing something for a particular computer, one, you understand the computer, but which function am I trying to deal with? Now, these operating systems come in multiple shapes and flavors. We're going to look at in this course, you're definitely going to spend most of the time in Windows, because from a usability standpoint, most end users use a Windows computer. Most. I don't know the percentages, but I'm guessing probably between 60 and 80% of the people use Windows-based. The school, Windows. But if you get to a career that's high in graphics, you may have it may be turned to a Mac operating system only because Macs are great with graphics. Or you can use, you're doing server work. The internet is just one big server relationship. All of them run by Linux, or often from a Unix standpoint. So that's another system we're going to look at is Linux. Yeah, we'll do a whole lot more detail a little bit later. So each one of these has different applications. Sometimes you've got a graphical, and they're nice pictures. Sometimes it'll be command driven. When you're on more of a server side, you're going to be command based, even though some will have a graphical user interface. But for the most part, your servers will be command based. Your individual devices or user devices will be graphical user interfaces. Some of the popular ones, I said there's Microsoft, Mac OS, Linux, and then you got Chrome OS. Each one of those has its place, its purpose, its pros and cons. But as a person in IT, you're probably going to need to know a little bit about all of them, or at least tying the basic functions of an operating system to what you're looking for and say, okay, how does my operating system X do something. I think it's a problem with file retrieval. Okay, every operating system does it. Now, how do I figure out which way does it go? Let's see. Now, every OS, how does it manage its hardware? For the most part, you've got device drivers. You've got part of the operating system has a kernel. Actually, it's the kernel is probably the driving force of the entire operating system. It's just, you think of a kernel of corn, it's just, that's the key to everything else is going on. But with that, it says, I need help from, while I'm dealing with a lot of main stuff, I need somebody to control my devices. So you got something called device drivers, which are just softwares that's embedded on the physical device, your end device, like a printer or network card or a scanner, and some part of it is in the operating system that says, okay, how am I going to communicate with that? Sometimes your CPUs have a, what is its bus width? How many bits of data can I send at one time? A lot of your older CPUs are 32-bit. Most of the newer ones are 64, and you're starting to see 128 starting to come into play, which basically means I can put more data on the system at one time than ever before. Let's see, I won't worry about any of this stuff. Now, every motherboard has firmware that is used to start controlling information, that sets up information to communicate with what does it connect to. When you power on or boot up your computer, it's looking at this Unified Extensible Firmware Interface, UEFI, and sometimes you'll see BIOS/UEFI to bring a system up. How do I get all the data installed? What physical devices are connected to me? What do I have a CD? Do I have a DVD? Do I have a printer attached to me? What kind of keyboard do I have? It's looking at all of that to say, so it can load the right software to make sure things are running correctly. Now, sometimes it's beneficial that you want to have multiple devices. So and you want to change which device you want to boot off of. So let's say I've got a DVD that I want my computer to boot off of instead of what's stored on my hard drive. You can change the boot order, and you'll see an example in that in the textbook so that you can see how to go about doing that. How the operating system controls its hard drive. So basically, how is a hard drive laid out so that it knows where data is located? So this section here goes through all of how a hard drive is organized and how data is found. Now, each of the operating system does something slightly different, but they're all trying to manage data on that hard drive. And I'll let you go through and see that. Now, how file systems work, basically, what am I trying to do? I'm trying to read, write data to my system. So I want to be able to name it, store it, organize it, move them, delete them. And it could be a all hard drive. It could be someplace else. It could be on a network drive. But in Windows, that hard drive has what they call a partition, or a section of the hard drive that's connected to your system there, that it says, hey, I've given it, Windows decided to start putting a letter in front, a designated drive letter. by default, usually it's either C or D. Most I've seen are C, but that's the letter delineation called a volume. Now, installing a file system, you need to understand what kind of data are you going to store, how much data is going to be stored on it. Do you want more than one drive on a physical drive? Now, we're not going to get into how to make that delineation at this point, but just to let you know, there are different ways of storing multiple volumes on it in the same physical. Now, every operating system has some kind of hierarchical organization so you can store information. It's called directories, folders, or subdirectories, or child directories. So just kind of get a sequence of lower probability of or being used. So just give an example here on Windows. Now every file on your computer has a path. It says it's got what drive it's on, what file it's on, what file extension, what directory, subdirectory is it in, and that path should tell you exactly how to get to that particular file. So as an example here, to get down to letter.docs, it's under data, it's under root directory, the C drive, which is the standard one for Linux. Then it's got /data, and you're comfortable with the backslashes. And then you've got your file extension. You got the file name, file extension. Now, Linux has, instead of having this C drive, its root it's indicated by just a /. Now, as you saw up here, you got the / for a Windows device. You got a / for a Linux-based operating system. Just something to think about when you put in a URL into a web browser. Which direction is your slashes going? I'll let you think about that for a second. That tells me that since I look up, let's see, do I have any? Yeah, even on this screen here, I've got several different slashes to get to this file. They're all slash going to the right. That's telling me that the operating system that's being used on this network to get to the internet through the internet is mainly a Linux-based operating system. So just something to keep in mind. But just know the home directory is just with a single /, and then all its subdirectories are based underneath that. Now, that subdirectory at that location there's a mount point. Basically, how is it connecting to my home directory? So I've got a mount point for a particular drive, for a medium in the subdirectory for media. So if I'm directing a flash drive or something, that's where that is located. So see that you have the flash drive. Now you've got different types of file system structures. And most of this is deal with how much data do I have access to. Some of the older systems who had access to one, you only had a 32-bit address, so you can only access that much data. So you had an organization called FAT32 file system. It worked well, but it had its limitations as to how much data it could actually access. Now you've got NTFS file system, which is most in play, is used, and it handles tons more data. Now you have EXFAT, which is used for large external storage devices, because now you got, using 64-bit wide. Now on Linux side, you've got extended file system. So you got an ext3 and 4, and basically 4 is the one that's now using 64-bit addressing to allow for larger applications. And then Apple has its own APFS to and how it organizes it. So just know that that information is available. Now, compatibility between them, Table 11.1 tells you yes or no what you can and can't do it. There are some tools that can be used to manage your hard drives. And as you'll notice, some of the notes in here, that's when you get to Linux, Mac, Linux, and Chrome are all Linux based. So you may see some of the commands over time being identical. Let's see. Now, if I want to do operating system installations, there are several different types that you can do. I can do a clean install, which basically means I've got a new computer or I've got an old computer, but I don't care about any of the data that's on there. I can then overwrite everything that's on the system and put everything in new. Now, I can upgrade, which says, okay, I got to log into the current operating system and then go from there and install system. So it could be an in-place upgrade, which says, hey, I'm just going to do things there, but basically means for Windows, you got to be at a certain starting point to be able to do an in-place upgrade to Windows 10 or Windows 11. Mac has a different way of doing this, but for the most part, you can get the same things between the Macs, between Linux, between Chrome. They all have how do I verify, and how do I install different operations. Now, once you done your install and stuff, what I have to do, I've got to bring the system up. I've got to boot the system up. Now, solid state drives, because there's no moving parts, are definitely the faster of the devices to bring your system up. So if you have a choice of swapping out or upgrading to a solid state disk drive or flash drive, I would do it only for speed. Otherwise, you're going to be waiting longer to boot. Now, I can change which device I'm booting off of, whether it's a flash drive, an external drive, or internal. We can change that. Now, you can play games with that. I don't think I sent any labs to that. Let's see. Now, some of the things that not every operating system runs forever. There is an end of life or a time period where a vendor will not support telephone calls or emails to upgrade their system, to make changes to them. So each one has its own. Some are, Windows 10 has been around probably the longest, probably for a lot of reasons, but you can change it. Mac OS changes about once a year. Linux, it really depends on the developer. Chrome, because it's a newer operating system, in a lot of cases, it has more frequent upgrades. Let's see. Anything else I need to? So this chapter has a lot of different stuff in it. How you treat your customers and the best things to do being a tech support, whether it's in person, in company, out of company, phone technician. That's in that first section. Then it's the systems. How do I modify changes and control environments? And then the third section is on networking, or the physical changes to the different operating systems to do some of those four major functions. So hopefully this chapter is not too difficult. Yes, a lot of different areas covered, but as a nice high level, what major things happens in an operating systems, this is it. So if you have any questions, let me know, and I'll talk to you next week.